Well, greetings, Mr. Kolazar's class. Today we're going to begin into the structure of the atom, and this kind of begins our section into actual chemistry. You always see these models of the atoms, objects moving around a center part, so we're going to begin to break down what each part's looking at. So to begin this chapter objectives, compare and contrast the atomic models of Democritus, Aristotle, and then the next chapter we're going to look at Dalton, Thomson, and Rutherford. And we're also going to look at today about Dalton's theory that explains the conservation of mass. So to begin with, Greek philosophers looked at the idea that, very simply, that all matter could be divided into four categories. And we could divide them endlessly, like if we could split something in half, so we had fire, earth, water, and air. And the idea was that, if you had a material, you could cut it in half, and then cut that in half, and that in half, and half, and half, and half, and half, and eventually you could just keep cutting it, and no matter how small, you could break it into a smaller part. And then the combination of the different ones, the fire and air, got you hot, the wet, the cold, and the dry, and that all of our elements came from one of these four sources, or all of our material was from one of these four sources, or combinations of them. Well, Democritus came around, and Democritus was the first one to actually start to think about the fact that if you cut something in half, and then cut it in half again, and then half again, and then half again, eventually you'd come up to just one little particle that couldn't be split anymore, and he came up with a term called atomos. We use that term now for the word atom. And the idea was that the atom was that smallest individual part. Believed that matter could not be created, nor destroyed, or further divided once you got to this atom. Now, atomos, unfortunately, Aristotle lived similar time, and he did not believe the idea about this empty space, and he believed that there were only four elements: earth, air, fire, and water. And because he was so well known as a philosopher of the time, everybody stuck with his ideas, even though we know them to be incorrect. And so poor Democritus was ignored, even though most of his ideas were right on track. It wasn't until almost 2,000 years later that we decided to start changing up the ideas. And here are 6 key ideas. There are 5 on this page. First off, Dalton came with the idea of the atomic theory. And first one was, matter is composed of extremely small particles called atoms. Democritus called them atomos. Atoms are indivisible and indestructible, meaning we can't break them down any further, and we can't get rid of them. Atoms are given a chemical element that are identical in size, mass, and chemical properties. 4. Different atoms combine in simple whole number ratios to form compounds. And 5. A chemical reaction, atoms are separated, combined, or rearranged. So with all of these, they were on the right track. Now, key is that a couple of them weren't quite right. So the ones that aren't quite right, we're going to fix up. So in your notes, atoms for number 2, atoms can be divided into smaller parts. So they are divisible and they are destructible. So during nuclear reactions, we can actually change those. So in a nuclear reactor or an atomic bomb, they can be changed from the ones that they are. And we're going to find out later on that the mass of identical elements or atoms can be different. We're going to find out this term is called isotopes. Have different mass but are the same elements. Besides that, he was pretty much on the right track with all of the rest of his ideas. The last one, number 6, Dalton's atomic theory also explained the conservation of mass. And the idea here is, this is a good one. We need this one. Atoms are separated, combined, or rearranged during a chemical reaction. So during a chemical reaction, atoms are separated, combined, or rearranged. They're not created, nor divided, nor destroyed during a reaction. So like if you had 4 of one chemical, could combine with 8 of another chemical, and in the end, you would have 4 of this new chemical. Now, their whole number ratios was also his nice idea there. So in the end, Dalton came up with studying the idea, more accurately determine the ratios of the elements involved in chemical reactions, Conclusions were the conservation of mass, saying that atoms in a chemical reactions are separated, combined, or rearranged, but atoms are not created, destroyed, or divided during these chemical reactions. And that's going to be our idea of the conservation of mass. So that's the beginning of our introduction to the atom.